Hi guys, so we are doing F3 today, which is basically linear maxima and minima. Very simple topic, just two concepts that we need to know, and once we are done with those, you are good to go for solving the questions based on that. So let's see what is the first of the two concepts. The first concept is you will be asked to find the maximum value of the product when the sum is constant. Maximum value of the product when the sum is constant. Let's first try and understand what exactly is meant by that by a very simple and an easy example. So suppose a plus b plus c is 18 given, and we are supposed to figure out the maximum value of the product abc. So abc का product maximum find करना है, and same three numbers, their sum is given as 18, which is constant. Now since we don't know the rule or the formula or the shortcut right now, we will do it with the layman's way. For example, there can be many possibilities in which the sum of the three numbers can be 18. Let's list down some of them. The first one is the most easy one, where all are equal. Each one of them is 6. Then suppose we start spreading out the numbers: 6, 7 and 5, 855 or 864, and so on. Many such possibilities are possible. And for those possibilities, whichever few that we have listed down from the many possibilities, if we now take the product, and you will realize some pattern which is happening. For example, in the first scenario where all the numbers are 6 each, when we take the product, it turns out to be 216. In the second scenario, it is 210. In the third one, it is 200. In the fourth one, it is 192, and so on. So what do we observe here is that when the numbers were equal, we are getting the maximum value of the product, which is 216. But as we keep on spreading out the numbers from each other further and further, what you observe as a trend is that the product is reducing and reducing. So one obviously scenario that we can shortlist from here is that the sum is constant and the product is maximum when all the numbers are equal, all of them are same. But hold on, there is another catch which we most of the times will not realize if we are not very careful with that. The examiner never talked about whether the numbers are positive or the negative numbers. He or she just mentioned that sum of three numbers is 18. And this is where our mental blockage will harm us big time. For example, whenever we are asked to assume something or substitute something, we never substitute negative numbers, we never substitute fractions. We always try to substitute nice simple values like 1 2 3 4 and so on, and that is where we will fail drastically. Now for example, here the negative numbers wala possibility we never explored. Now, and when we start exploring, you will realize something entirely different altogether. For example, three numbers, suppose some of them is negative, all two of them are negative, -10 and one of them is positive, which is 38. You realize the sum is 18 plus 18, that doesn't change. But look at the product turns out to be 3800, which is definitely way more than 216. So how do we decide? Now, for all you know, we can keep doing this all day long, keep spreading out the numbers further and further in the negative part, in the negative zone, and you keep on getting even higher and higher product. So practically after a couple of examples, you realize that there is no stopping to this. And when we consider the negative scenario, there are literally infinite cases possible. So to limit those infinite cases, what the rule is, they have put a cap on the rule. There is a restriction on the rule, that this restriction, that the sum is constant and the product is maximum when all are equal. This rule is only and only applicable if the numbers are positive, and that is why these are going to be your checkpoints. If the question satisfies these criteria, only and only then you are going to apply the rules. So the official statement coming up right now, which what you are going to remember, which is the product of the set of the positive numbers, the emphasis is on the correct wordings, positive numbers having a constant sum is maximum when all the numbers are equal. Remember this, as a benchmark, because this is what you are going to use for solving the question. This will give you the ideas. So this is the first of the rules. The second of the rules is exactly opposite of that. Minimum value of the sum when the product is constant. Ulta hai. In the previous scenario, we had sum constant and maximum value of the product. In the second scenario, we are going to find the minimum value of the sum when the product is constant. As usual, we still don't know the rule. Let's go it. Let's consider one example, solve it with all possibilities and layman's approach, and then finalize something as a final conclusion. So suppose ABCD, four numbers, their product is 625, and we are going to find out the minimum sum of the same four numbers, A plus B plus C plus D. What do we do here? Again, let's consider a few possibilities where the product of four numbers is 625. For example, all of them are equal, which is 5 each. You spread out the numbers 1, 5, 5, 25. You further spread them out 1, 1, 25, 25, or for all you know, three numbers are 1 each and one of them is 625. All of these scenarios and many such more scenarios, the product will be 625, no doubts about that whatsoever. But now since we start taking the sum, again what you realize is, as we keep on spreading out the numbers further and further, the sum starts increasing. And if we are considering only these many possibilities and we were supposed to figure out the minimum sum, you realize all of the numbers has to be same. And again, before we confirm this rule, we have never explored the negative scenario, because four numbers product is positive, all four can be negative, the product will be still positive, or couple of them can be positive, couple of them can be negative, the product will still be positive. And again, when we consider the negative wala scenario, what you end up realizing is the sum keeps on reducing even further, and we can do this all day long. And that means there will be again infinite scenarios in the negative part of the consideration, and that is why we need to ignore this. And there is a cap, again the same cap on the rule as well, that this minimum value of the sum when the product is constant, when all are equal, is only and only applicable when the numbers are positive. Very, very critical observations these are, and you have to be very thorough with them. Only then you will not make a mistake. So official statement coming up one more time. The sum of the set of the positive numbers having a constant product is minimum when all the numbers are equal. These are the two rules you are going to remember, which will help you to simplify the questions. So two simple rules we have learned. Mostly questions are based on exactly the same idea, and then there will be some add-ons at the end part of the topic. So first one, we have to find the maximum value of the product ABC if the sum is 20. If you remember the rule, for the product to be maximum, the sum has to be constant, and the sum is constant, which is mentioned there. And the rule was, for the product to be maximum, all the numbers have to be equal. So each of the number have to be equal. That means all of them have to be 20 by 3. Now don't worry, I know you must be thinking 20 by 3 is a decimal value. We had to have the proper numbers or anything as such in terms of integers. But if you read the question, nothing of that sort is mentioned. If the question would have been talking that the ABC have to be integers, then we would have gone for the proper numbers, that most of you might have got it as the answer. But because the rule is very straightforward, that for the product to be maximum, the numbers have to be equal, even though they are supposed to be decimal numbers. So each number is 20 by 3, and the product of all those three numbers ABC, which is 20 by 3, the whole cube, will be 8000 upon 27, which I think when you actually divide will be 296 point something. And if the question would have talked about integers, that ABC have to be integers, then obviously three numbers, the sum is 20, the combination is not possible except 776 as the biggest product of combination, which is 49 6, that is 294, and 296 is definitely more than 294. We'll have to stick with this answer, and because of which the answer is not 294. So don't mark that. It is also present in the option, but you will have to be thorough with the ideas that the product is only maximum if the numbers are equal. So option 5 as the first one. Second one, a plus b plus c is 18. Find the maximum value of the product a minus 2, b plus 3 and c minus 4 if a is greater than 2, b is greater than minus 3 and c is greater than 4. So we are not supposed to find out the maximum value of the product ABC. So students usually mark 216 as the answer, which is incorrect. We're supposed to find out the maximum value of the product a minus 2, b plus 3 and c minus 4. So we'll first have to make sure that the sum is constant for those numbers. So let's check that. Let's add all the numbers for which we were supposed to find out the maximum product. When you add these three numbers, what you will end up getting is a plus b plus c minus 2 plus 3 minus 4. And we already know the value of a plus b plus c, which is 18. So when you substitute and solve, you will get the value as 15. So yes, for the term that we were supposed to find out the maximum product, the sum is positive, the sum is constant, which is 15. And now let's apply the rule that the product is maximum if the sum is constant and all the numbers are equal. So three numbers whose sum is 15, they have to be equal. That means each of them have to be 5. That means the product will be 125. So 125 is your answer. But in such sorts of question, examiner can go one step ahead and ask you, find the values of ABC. And that means you will have to substitute. You know a minus 2 is 5. So solving that, you will get a as 7. B plus 3 is 5. So B will be 2. And C minus 4 is 5. So C will be 9. And when you add a plus B plus C, you will get the original value, which is 18. So answer is 125 and not 216. So जिसका प्रोडक्ट मैक्सिमम चाहिए उसी का सम कांस्टेंट होना चाहिए, किसी और का नहीं चलेगा. That is something you'll have to remember very carefully going forward. Third one, sum a plus b plus c is 18. Find the maximum value of the product a cube plus a square b cube and c raised to 4 if a b c are greater than 0, that is positive. Again, very different question that what we have done so far. That is, instead of linear terms, we have the powers now. So what you will have to do is, and you can remember this as a shortcut for all such types of the question, whatever is the sum, you will have to straight away divide that in the ratio of the powers. So sum is 18, we'll have to divide that in the ratio of the powers, that is 2 is to 3 is to 4. So when you divide 18 in the ratio of 2 is to 3 is to 4, the values that you end up getting are 4, 6 and 8. So substitute in the place of ABC, the value is 4, 6, 8. And when you do that, straight away you get the answer as 4 square, 6 cube and 8 raised to 4, which is option 3 for the third one. Divide the sum in the ratio of the powers. That is the shortcut. Fourth one, ABCD, the product is given which is constant, which is 20, and we were supposed to find the minimum value of the sum a plus b plus c plus d, provided all the four numbers are positive. So again, जिसका minimum sum निकालना है उसी का product constant होना चाहिए and सारे numbers positive होने चाहिए. So if you remember the rule, the sum is minimum if all the numbers are positive and the product is constant if all of them are equal. So all of them are equal, यानी a is equal to b is equal to c is equal to d. All of them are equal. So that means instead of b, c, d, substitute a only. So you get the expression as a raised to 4 as 20. In the original product, instead of b, c, d, substitute a. So you get a raised to 4 as 20. Solve that, you will get a ka value as 4th root of 20. So each of the numbers a, b, c, d is equal to 4th root of 20. And we were supposed to add all of them a plus b plus c plus d. The value will be 4 times 4th root of 20. So make a small correction, I think, in the options as well. 4 times 4th root of 20 is the correct answer for this question. So the rule, if the product is constant, the sum will be minimum if all the numbers are equal. The second rule that we have discussed in the concept of linear maximum minimum. So as I said, first four questions based on the two rules that we have studied. Fifth and sixth one will skip them because I have not seen them over last 2 3 years in the exam, and the risk reward ratio is definitely not in favor because they are way too technical in terms of the graphical language. This is like the core mathematics is all about. So if we'll skip this for time being, if anyone is interested and you try solve them, let me know. If you need any help, I'll be very happy to help you with the solution and the explanation of them. Seventh one. Now these are some sorts of questions which are based on the modulus, the minimum value of the expression. So again, there are a couple of rules that we are going to discuss here as well. So for the minimum value, mod of x minus 4 and plus mod of x minus 10, plot the roots in the ascending order, that is 4 and 10. Now there is a very simple rule that whenever there are even number of moduluses, 2, 4 or 6, the minima of the expression happens at the middlemost range. What you are going to remember as a shortcut, for the even number of modulus, the minima happens at the middlemost range of x. So what that means simply is 4 to 10 is our middlemost range. So what you can do is pick any values from 4 to 10 and even including 4 and 10 and substitute that in the original expression in the place of x. Mod of x minus 4 plus mod of x minus 10. Substitute any damn value between 4 and 10, including 4 and 10, and you will have the same answer every single time. And you can try experimenting with this. Substitute 4, substitute 5, 6, 7, 8, 9, 10. For all these values, the final value of the expression will always remain the 6, and that will be the minimum value of the function. So the answer is option 2. So the minimum value of the function is 6, and it happens when x is between 4 and 10, including 4 and 10. So that is the rule that you can remember. In case of even number of modulus, the minima will happen at the middlemost range. Remember that. Similarly, the next one. Now there are clearly three moduluses. If you plot the numbers in the ascending order on the number line, it will be 4, 10, and 16. And because there are three modulus, the rule is in case of odd number of moduluses, minima happens at the middlemost range. In case of odd number of moduluses, minima happens at the middlemost value of x. So 4, 10, and 16. These are the three values. The middlemost value, because there are odd number of moduluses, three moduluses. The middlemost value is 10. So what you are going to do is substitute x is equal to 10 in the original expression, and you'll get the answer, which is 12. So the answer is option 3. The minimum value of the function is 12, and it happens when x is equal to 10. Ninth one. Clearly you see there are 4 moduluses, so even modulus wala rule will be applicable, but for that you will need the roots in the ascending order on the number line, that is 4, 10, 16, 22. And 4, 10, 16, 22, because there are even number of moduluses, the minima will happen for the middlemost range. So what you can do is between 10 and 16, you can substitute any damn value, including 10 and 16, in the original expression, and you'll every time get the same answer, which will be the minimum value of the expression, which I think is 24. So answer is 24 for this particular question. Even number of modulus, minima happens at the middlemost range of x between 10 and 16, including both of them. Substitute 10, 11, 12, 13, 14, 15, 16, any damn value. Every time you'll get 24 as the answer. You can verify that in the original expression. That is the rule. Okay, the last one, the 10th one. What do they have? X, Y, Z be the distinct positive integers. Distinct याने they'll all have to be different. The sum is 15. Now, obviously, if you remember the rule for the product to be maximum, the sum has to be constant and the numbers are supposed to be all equal. So the numbers will be 555, but that is like the best case scenario. Now, why they cannot be 555 here? Because of the wordings of the question. They want distinct positive integers. They all have to be different. So obviously, when you were doing the concept, we had created some cases as a layman's explanation. And if you had understand the pattern was that the product will always be maximum when the numbers are equal. And as you keep spreading out the numbers more away from each other, the product keeps on decreasing. So obviously, we want best of the both worlds. We want the maximum product, but we cannot have the equal combination because the question wants the numbers to be different. So obviously, instead of 555, the next best combination will be try to keep the numbers as closely knit as possible. So let's decrease one and let's increase one. So the combination has to be 456 or 654 or it doesn't matter, XYZ, whichever value you substitute. So what you are going to do is in the original expression, substitute XYZ as 456 or 654 or 546. It doesn't matter, and you will have your answer. Substitute this in the original expression and you will get your final answer, which I think is 194, which is first option for the 10th one. So linear maxima minima, super easy idea. Just two rules, product and the sum, based on which we had four questions. And then next three questions were based on the modulus, two straightforward general cases you have to remember. And the last one again, back to the normal that we have been doing as the typical bread and butter type questions in terms of solving. So folks, with this, we are done with linear maxima minima. Thank you so much.